Hello everyone, my name is Dr. Somenath Ghatak. We will be seeing a confocal system for sure, that is the LSM 980 from Carl Zeiss India. But in addition to LSM 980, we also have a dedicated hardware based super resolution, that is the Airyscan 2. So let's see what the system has to offer. So first of all, this is Axio Observer 7 and this is a fully motorized inverted fluorescence microscope. Onto this a very high end and sophisticated system, we also have LSM 980 scan head, and this LSM 980 scan head is further has an attachment in the form of a Airyscan 2. So what is this Airyscan 2 and how this Airyscan 2 is going to offer you a super resolution image is what we are going to discuss in details. Now that you have seen the system with all the hardware attachments, what actually is present in this configuration, then comes to what is the resolution you are going to get with a super resolution module, that is a dedicated Airyscan module. In a confocal system, you will be getting an XY resolution of something around 250 nanometers in XY, and in Z around 500 or even more than that nanometer resolution. But when you talk of Airyscan resolution, the Airyscan, obviously when we are claiming it as a dedicated super resolution module, so this attachment or this dedicated hardware will give you a resolution of 120 to 130 nanometer in XY, and in the Z it will give a 350 nanometer resolution. So which means that almost there is a jump of 100 nanometer difference from a standard confocal to a Airyscan resolution, and that is going to give you a more meaningful and a more resolved data. Okay, now what is the Airyscan, why it is giving this improved resolution, and what is the hardware behind it? So I'll just give a brief outline about how the Airyscan works. Now Airyscan, as you saw, it's a dedicated hardware for the detector. So basically you can take it as a detector, a separate detector which works in combination with other set of detectors which are available in the system. Now this detector is unique in a way. This is not a regular PMT detector which you are having as a standard configuration with a confocal system, but on the other side in Airyscan we basically have 32 elements which is in the shape of a hexagon, and each of this hexagon 32 put in a honeycomb structure, so that each of these 32 elements in a Airyscan individually generates one PSF. So instead of having one pinhole and one PSF corresponding to that pinhole, in Airyscan we can generate 32 different PSFs for the same plane of focus. Now what this attributes, this 32 attributes, it actually is able to differentiate different orders of light. It actually identifies which is the 0th order, 1st order, 2nd order, and eventually the 3rd order of the light or the frequencies which is actually detecting. Based on this, there is an algorithm called Shepard sum, and this algorithm attributes or actually accumulates all the information from 32 individual PSFs and attributes to the central element which is the central PSF, and that is why we are able to achieve a super resolution data from a normal confocal image. So why it is different? Because it is not a regular PMT. Second, it works on 32 individual PSF which is by the virtue of 32 separate elements, and third, you get a resolved much better resolved data compared to a confocal system. Now this is a partly a deconvolution algorithm, partly a Shepard sum algorithm which works all together to give you a better resolved data, but there is always a dedicated hardware involved in it. Without the hardware, if you are just taking the raw image or the raw confocal data and you try to do a lot of algorithms for per se like a deconvolution algorithm and try to extrapolate the super resolution data, then that data is basically caused due to or extracted by pixel reassignment. There is no raw data collected is actually a confocal image. It is not better than that. But on the other hand, when I talk of Airyscan, by taking 32 different PSFs, we are not only actually enriching or collecting more raw data in order to come to a super resolution data, but Also we are collecting individuals and we are also dividing them into different orders of light. So that also helps me in removing the non-significant or maybe the blurry light or the non-focused signal which still is being collected to some extent in a normal confocal system. Thus we are able to achieve a much sharper and clearer with a better resolved scientific data using the Airyscan 2.